So in this video I'm going to discuss Codeforces round 940 rated for Division 2. So I will be solving first three problems and showing the code also, but I will be also discussing the fourth problem, that is D problem, and the intuition part of that problem. So let's start with problem A, that is a Stickogon. So in this question I will be given n sticks of length a1, a2 and an, and I can form a regular sided equal side polygon from that, and I have to tell them what is the maximum number of polygon you can construct from that stick, and you cannot use one stick more than one. So what is the minimum possible sticks required to form a polygon? That is three sticks. You cannot form a polygon with two sticks and one stick. So minimum number of sticks required to form a polygon is three sticks. So you will utilize the sticks in this manner only. So try to form the sticks. Try to construct polygon from in a pair of three sticks. So that will you will get the in that way you will get the maximum number of polygon formed. For example, in this case you have total 3 number of 4s and total 5 number of 2s. So total you can make at most 2 number of maximum polygons. One polygon from 4 and one polygon from 2. And the remaining 2 in this set will be remain unused. So that's how you can form the maximum number of polygon in this question. So let's now discuss the problem B, that is a bit of a construction. So in this question you are given a number n or a number n and a number k. So you have to divide you have to construct an array of total n size such that the sum of array is equal to k, and also you have to also make sure a condition that or operation of all the number is maximized, and the number of ones in the final or of the all the numbers is maximum. For example, let's suppose you are having a test case like this. Let me take it. Let's suppose you are having a test case like 5. So how you can divide 5 in two numbers such that the OR of final end contains the maximum number of 1. So you can divide 5 into 1 and 4. Okay, 1 and 4. So what is the binary representation of 1? That is 0, comma 1. And what is a binary representation of 4? That is 1, 0, 0. So the OR of this, OR of both of these equal to 1, 0, 1. So that is a maximum number of 1 you can achieve by dividing 5 into 2 parts. So how to generalize this solution, which means how to get the maximum number of ones by using this operation. So tell me, let's suppose I am giving a number like 33. So in 33, what is the maximum possible one you can get? So I have, so there can be many answers. So let me divide into power of 2. That is, first I will get 1, 2, then 4, and then 8, and next is 16, and next is 32. So tell me, what is the maximum possible number of ones in 33 you can get? So that is equal to the largest power of 2, which is smaller than equal to n minus 1. But why? So what is the largest power of 2 which is smaller than and equal to 33? That is 32. Okay, so in this case it is 32, right? So what is the number of ones in the 32? The number of ones in 32 are 1 only, that is 1, 0, 0, 0, 0 and 0. But how many number of ones are there in 31? That is equal to 1, 1, 1, 1, 1, and here it is 0. So that is a maximum number of 1 you can achieve, because the largest power of 2 which is smaller than or equal to your number minus 1 will give you the maximum number of ones in your final answer, because the value of answer does not matter. It means they are not saying you like you have to maximize the sum. They are only saying you that you have to maximize the number of ones in the final configuration. So answer is simple. I will repeat again that the largest power of 2 smaller than or equal to k minus 1 is your answer. So let's suppose in this case let's suppose if your k is equal if your n is equal to 1, which means you can only divide into one number of parts. So in this case the answer is simply that number which you are given, because you cannot divide. But if your answer is not equal to 1, which means if your k is n is greater than or equal to 2, then in that case the answer would be the largest power of 2 smaller than or equal to n minus 1. That will be you right here, and this number minus, for example it is 31. In this case this number would be 31. So in the second position simply write 33 minus 31. What is the remaining sum? For example 2. Okay, and the by default make the rest of the numbers as 0, 0, 0, 0. So that's how you can get the maximum number of ones in this configuration. So let's now discuss the problem C, that is how does the rook move. So this problem is pretty much good problem, I could say. So in this question you are given a n into n chessboard. Okay, and you will take turns alternatively, which means first of all you place a rook, you place black white rook and black rook on the board, and there's a valid move. A valid move is that move in which you cannot place a rook such that the other rook attacks that rook, which means you cannot place the rook in the same rows and column of that rook. So what you will do? So similarly, you are playing with a computer. So if you are playing a move like RNC, then computer will play move C, R. But if you are if you are placing a rook on a diagonal, then the computer cannot mirror your move and simply skips his turn. So totally you are given a k set of moves. Okay, k set of moves are given to me, in which the computer tries each and every step to mimic. Which means if you are moving a R into C RC move, then the computer will move CR move. Okay, so that's how the computer is moving. So after k moves, you will now continue the game. Okay, so after k moves, you will now continue the game. Now after continuing, how many possible different configuration of board will be there, such that you will if you continue playing after k moves. So how many different possible configuration are there? Then print the answer modulo 10 to the power 9 plus 7. So how you can find the answer. So it is a pretty much simply greedy problem, or I can say DP problem. Okay, so but how? So let me teach you here. Okay, so let's suppose you are given a matrix. Okay, I am making a matrix over here. Let it is an n into n chessboard. Let's suppose make it into 5 into 5 chessboard. Okay, great. So 1, 2, 3 and 4. Okay, so similarly let's suppose your rook is moving here. Let's suppose you're placing a rook over here. Okay, and the computer is placing your rook over here because it is only mirroring your uh, moves. Okay, great. So let's suppose you are now placing a rook over here. Okay, it is blue. Let's suppose you are placing a rook over here. Then where will the computer move? The computer will simply place rook over here. Okay, great. So let's suppose there are only two moves. Let's suppose k is equal to 2, which means you're previously playing on only two moves. So by playing two moves, you have already blocked some number of column and rows already. Let's suppose what is the index of this. The index of this is 2 comma 1. Okay, 2 comma 1. Great. Now what is the index of this? The index of this is simply 1 2 3 4 1 2 3. That is 4 comma 3. Okay, so now you can see some number of rows are already blocked. What are those rows? The rows are simply 2 1 4 and 3, which means after that you cannot place rook on these rows. So only one row is left. Okay, if only one row is left, you're left with no option. The answer is simply 1 in this case. So but simply mean you're not moving. Let's suppose in this case, let's your k is equal to 1 only. Okay, your k is equal to 1 only, and you are only moving this move. So your k is equal to 1, your k is equal to 1, and you are only moving this move. So what is the index of this? The index of is this 2 comma 1. So in the set of 5, that is 1 2 3 4 5, these are simply number of rows which you are given. 1 2 3 4 5, 1 2 3 4 5. Okay, there's also case like if you're moving a move like r comma c, if you're moving a move like r comma c, and computer will move c comma r. Okay, which means these both rows and column will be blocked after moving. There's no other chance, because you are moving r comma c and computer is moving c comma r, so both the r and c will be blocked. Okay, so according the moves, if you are moving 2 comma 1 and computer is moving 1 comma 2, then in your final answer 1 and 2 will both be discarded. So you will only treat your answer as 3 comma 3 grid. Okay, so let me now make another grid, which means you will only iterate in this grid, that is 3 comma 3 grid only. Okay, so in this question, so in this grid, now where you can place your rook. So how to place rook in this grid? So let's suppose you are only placing rooks in the end part. Okay, in the end row only. For the simplicity, I am taking this. You're only placing rook in the end part of your matrix. So if you try to place a rook, a rook where r is equal to c, which means on a diagonal, which means your r is equal to c. So then how many possible ways are there? Ways are there? If you're placing a rook on a diagonal, there's only one possible way. That is it. So tell me, on the last row, you can on this and this row only. Tell me what are the number of columns are there such that r is equal to c. there is only one column such that r is equal to c. So you cannot move any further. So okay, so in the next case is like, how many moves are there in which r is not equal to c? How many moves are there in which r is not equal to c? So that is 2 into I minus 1. Similarly, so in this case, what is your n? Let me repeat it again. So in this case, let's suppose what your n is equal to 3 only. Okay, your n my n is my n is 3 only. So how many possible number of ways are there in the last row and column such that r is not equal to c? That is only 2 into n minus 1. So why? Because what is a 2 into n minus 1? Simply 2 into n minus 1. So n minus 1 is 2. Okay, if my n is equal to 3, then my n minus 1 would be 1, would be 2 only. So what are those columns? Those columns are simply this column, this column, and this column, and this column. Okay, because if you are moving r comma c, the computer will move c comma r. If you are moving r comma c, the computer will move c comma r. So that's how you will also count computer's part also. So if your n is equal to 3, then one way is like you are moving on the you are moving a move where r is equal to c. Then how many ways are there? There only one way, that is simply this diagonal. Okay, simply this uh, index on the last row and column. And if you are moving a move like where r is not equal to c, then how many possible boxes are there? There total 2 into n minus 1 boxes. Okay, great. So let me more further generalize this. Let me again make that grid. This is 3 into 3 grid. Okay, okay. So let me make a much bigger grid for this. Okay, so this is a 4 into 4 grid. Okay, so how many possible ways are there in the last one column? In the last one column, such that r is equal to c. There is only one block. This is block. So what is the answer for? Let's suppose answer for, I am liking it. Answer for 4, which means answer for 4 into 4 grid. That is 1 into, because it is a case where r is equal to c. It is a case where r is equal to c. I am writing here. It is a case where r is equal to c. Okay, that is 1 into answer of 3, because that is what I am asking for. Because if your r is equal to c, then you are only reducing your column grid to 1 only. Because if r is equal to c, let's suppose your case is like 1, 2, 3, and 4, and you are placing on 4 into 4, then your 3 grid are left, then your 3 rows and column are left. So similarly, answer 1 into answer of 3. Okay, great. Plus what? So if your r is not equal to c, if your r is not equal to c, so in this case, how many possible ways are there? There are total 2 into 4 minus 1, that is 2 into 3 cases. 3 are this and 3 are this. So that's why 2 into 3 cases. uh, if I want to generalize this, that is equal to 2 into n minus 2, uh, n minus 1. Okay, so in this case, if your r is equal to c, then how many column are reducing in the end? So let me repeat this example only. Let's suppose your in this case your row is equal to 4 and column is equal to 1. Okay, so if your row is equal to 1, column is equal to 1, okay, which means you are placing over here. If you are placing over here, then computer will place a move over here. Okay, great. Yes, computer will computer will place rook over here. So your two rows are cutting down. So in this case, you will simply multiply it with answer of n minus 2, because if your r is not equal to c, then your number of grid are decreasing by 2. But if your r is equal to c, your number of grid are only decreasing by 1. So simply this is a DP state which you have to follow and find the answer. So if I show the code is also easy. So first of all, find the number. First of all, I'm counting the number of rows and column remaining after the k moves. Okay, that is simply putting them into a set and simply finding the number of rows and column left in the end after subtracting the n from after subtracting the n minus set size of the set. Okay, now what is my dp? Dp is simply dp of n minus 1. That is, in this case, this is a case where r is equal to c. Okay, and this is a case where r is not equal to c. Okay, so simply in this case the answer is 2 into n minus 1 multiplied by dp of n minus 2. So that's how you can solve this problem. So this is a pretty much good problem, I could say, according to C problem. So let's now discuss the problem body. I will only tell you the intuition part of the problem body. Okay. So let me tell you the Let now understand the problem. So in this question, you are given a array a1, a2, and an. Okay, and you have to find tuples x, y, z such that these tuples are simply representing the index. Okay, index in this array only, such that XOR from x to y. Okay, this is the function you can see. This is simply XOR from x to y, XOR then again XOR from y to z should be greater than uh, XOR of x to z. So let me tell you here only. It is pretty much complicated, I could say. So let's suppose you are given an array like two. I'm only writing the index part. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, so these are the this is the array given to you. Okay, this is the array given to me. So how to find the answer? So what is the problem asking you to do? Simply make a XOR from this to this. Okay, and make XOR from this to this. So let's suppose in this case your x is equal to 1 and your y is equal to 4 and your z is equal to, what is z, is equal to 1 2 3 4 5 6. Okay, 6. So what is the problem asking you to do, telling you to do? So firstly make a XOR from 1 to 4, then make a XOR from 4 to 6, and find and XOR both of them. Okay, XOR both of them. So it should be what is the condition? It should be greater than or equal to, only greater than, it should be greater than XOR from 1 to 6. So you may be saying that it is a one and only same thing, but it is not. Why? Because 4 is coming twice. Okay, because 4 is coming twice, and there is a property of XOR that same, that let's suppose 4 XOR 4 is always equal to 0, which means making XOR of two equal numbers will always give you 0. That is a pretty much good case. I think you know already. So if you're so let me now let me now shorten the equation which is given to you. So the equation is given to is like XOR, function from x to y, XOR, that is, it is XOR symbol. Let me make it more clear. XOR from y to z, and it should be greater than XOR from x to z. Okay, so now you can see the, let me move that part. Now you can see in this equation your y is coming twice. Okay, yes, my y is coming twice. So which means what question is simply asking you to do is like XOR from y to x x to y minus 1. Okay, and this whole XOR should be again be XORed with the y plus 1 XOR till z, and this equation should be greater than x y till XOR till z. Okay, so which means what question is simply, let's suppose I will again make an array like 1 2 3 4 5 6 7. So you have to find an index, like for example this is your y index. So you have to find an index such that if you are removing, let's suppose you are making a XOR from this to this. Let's suppose you're making a XOR from 1 to 6. Okay, I'm making XOR from 1 to 6. So if you remove 4 from this whole XOR, then your final value should increase. Or I could say, if you add a XOR in this part and this, if you add the XOR of 4 in 1 to 3 till 1 to 3 and 5 to 6, the whole value should finally be decreased. Okay, so how you can achieve this? So this is the final configuration, I could say. Okay, which means, let me repeat it again. So XOR from x to y minus 1. Okay, this is written over here. XOR from x to y minus 1, XOR from y plus 1 to z should be greater than XOR from z x to z, which means adding a XOR of y should decrease the value. Okay, which means adding the value of XOR should decrease the value, or I could say removing the value of y should increase the value. So that is what question asking you to do. This is a shortened notation. So how you can increase or decrease the value of this? Okay, so this is the, simply I could say the, so let me tell you how you can simply decrease the value by adding the, by adding 4 in your final, by adding the y in your final answer. So take a y, take a y, and find the most let's suppose I'm taking a y over here. Okay, taking a y over here and find the most significant bit in y. Okay, I'm in MSB. Find the MSB of y, which is most significant bit. Okay, and try to find. Uh, let's suppose there's a number. Let's suppose a and there's a number b. Okay, I'll tell you what is this. So a and b. So simply, what is a? A is XOR from x to y minus 1. Okay, and what is b? B is XOR from y plus 1 to z. Okay, so this is the value given to you. Your a is XOR from x to y minus 1. Your b is XOR from x plus 1, y plus 1 to z. Okay, so try to find such that uh, what is uh, yes, try to find such that the what is the MSB. Let me back to that part. So let's suppose the MSB, the most significant of y. Let's suppose the uh, I'm taking just a random example, it's m. Okay, uh, let me change the color. So the most significant bit is at the mth position in y. Okay, the most significant bit in the y is at mth position. Okay, so try to find that the mth position of a is, let's suppose, 1, and mth position of b should be 0. Okay, and it could be another vice versa also, or mth bit of a can be 0 and mth bit of b can be equal to 1 also, which means they should be inverse of each other in both of the cases. Okay, try to make inverse in both of the cases. If your most significant, if the let me repeat it again, if the most significant of bit of y is m. Okay, let's suppose the most significant bit of y is m, then the mth position in a should be 1 and mth position in b should be 0. Similarly, if mth position in a is 0, then mth position in b should be equal to 1. Okay, so what I am trying to do is like here. Okay, so what is the final configuration of it? If you do the XOR of 1 XOR 0, that is always equal to 0. Okay, great, it is always equal to 0, and you know the mth bit of y is set. Okay, if you make a 0 XOR 1, let me make it another again also. So you know the mth bit of a is 1 and mth bit of b is 0, or it could be 1001, which means at the final you will get 10, you will get the mth position as a 0 in the a XOR b. That is simply this equation. In this equation you will always get the mth position as 0. Okay, now if you make a XOR from with 0 with 1. Okay, you make a XOR of 1 with 0. What is now where is this? There is 1. Now where is this coming from? This one is coming from y. That is the most significant bit of y. Okay, so if you make it like this, which means 0 XOR 1, that is always equal to 0, which means you are always decreasing the most significant bit. If you are always decreasing the most significant bit, this will always decrease your answer. That's how you can get the answer. Okay, so let me repeat it again. I think it is more complicated, I could say. So you will find the, let me repeat it again. First of all, find the most significant bit of y. Okay, that is MSB of y. Find the MSB of y. Okay, you have find. Now try to find such that the MSB of a, that is XOR from y to x, x from y minus 1, that is a. The mth bit of a should be 1 and mth bit of b should be 0, or vice versa, which means the mth bit of both a and b should not be equal. Okay, now if you make the XOR of a and b, that is this equation. If you make a XOR of this equation, you will always get a 0. Okay, I will always get a 0. Now if you make a XOR from 0 to 1, then you will always get a 0 also. So that's how you will decrease the value by adding the y in your final configuration. So this is the intuition of problem number D. So you can find the code in the editorial part more clearly. So this is about today's video. So if you have any doubt, you can comment me down, and till then stay tuned for the next one. Thank you.